Okay guys, I'll say a little bit more about transformations in this section, which deals with them in a higher level of difficulty really, and it involves powers really. That's the only additional problem, complexity thrown in here in these ones, as averse to the previous section. So for example, how would you find out solve for x for this equation here, x squared? How would you rearrange it for x equals a squared plus b squared? So you want to undo a square. Here you want to undo a cube, and here you want to undo a power 4. Well, you'd simply use the rules for indices, power u times, and I've written down the rule for indices here. So this is a general formula, x to the a to the power b, all to the power b is x to the a times b, that's a rule for indices. So you want to invoke that rule here, for example, on the first one then. So to undo a square, what you customarily do is you square root. So if we square rooted both sides then, so I'm going to move this out of the way here for the time being. We'll deal with those later. And now we're going to square root both sides because we have to do the same thing to both sides. Whatever we do to this side of an equation, we have to do exactly the same thing to this side. And I'm saying that we need to square root. Square root is akin to power half. So that square root is just a different notation than what we're saying is take this to the power half. So I'm going to write it slightly long-windedly. So here then we'd have x squared, and the square root of that would be power half on that side. Now, using the rules for indices, that power u times, so 2 times half would give you x to the 1, which is x. So to undo a square, and to get back to x, you square root. So you end up with then the square root of this side must equal then the square root of this side. So that would be power half, or square root of the whole thing, in that notation. So there's the answer then for the first one then. So we could simply write then here, just write x equals and square root both sides, and that would be the answer. Now let's have a look at another question. Let's do the second one then. Let's get rid of that. And let's have a go at the next one now. So let's drag this one up. And let's do a cube, for example, just to illustrate this. Now it wouldn't surprise you to undo a cube that you cube root, because the notation for cube root is the notation we use, two notations. We can use either cube root with a little 3 there, and that means cube root, and that's basically saying power third. That's what that notation is. This is what it means, it's power third. So let's cube root both sides then, and do that problem then. So I'm claiming that to undo a cube, you cube root. Let's have a look at that. So cube root both sides then. So x to the third cubed to the power third. Can you see 3 times a third equals x to the 1? That's why we're doing a third, because of that power. So it's 1 over the number that's here. So that would give us on the left x, and we'd end up with a squared minus b squared. Now you could put that all in a bracket and do power third, or you can use this notation here, power third. Okay, so that's that one done. Now it wouldn't. Again, I'm going to drag it out here, but I'm going to do the last little exercise just to illustrate what we're doing. So let's move this over, and let's do x to the 4. So let's do this one. Now again, I'm going to do it a bit quicker. Let's take the 4th root for this problem. So we're going to take the 4th root on both sides. So the 4th root of this will be x, won't it? Because 4 times a quarter is 1. And then you've got a squared b squared to the power quarter, which you can write like so. And you could actually use other properties of indices to tidy this up, because the product to a power is just the separate constituent parts of the product to that power. That's another rule for indices. So while we've got it here, we might as well do it just to illustrate that you can simplify the right hand sides when you solve these sorts of problems. Power u times, so that would be a to the half. 2 times a quarter is a half, and 2 times a half, I put a half, a quarter of course, is a half again. And you could write that as b. I'll get there in the end, sorry about that. B, trying to jump the gun. And you could combine that actually at the end as well. So that would be the square root of AB if you wished. There's lots of different ways to write it anyways. But the point of this little intro is just to illustrate the extra property that we didn't use in the previous section, that if you have a power, you move everything around so you have your term that you want to rearrange it for here. And then to get x, you would just take the square root or the cube root or the fourth root. The only other thing to say is that when you do square root something, you'll get a plus and a minus solutions. There's two possibilities when you square root, because when you go back to squaring, you'll get a plus. So a square root always comes with a plus and a minus in the solution on the right hand side. So this one will be plus and minus square root of that. The cube root doesn't, because a cube root of a minus number is negative. A cube root of a positive number is positive. The fourth root, again, that has two, doesn't it? Two possibilities that we need to cater for and write down in the answer. So bear those thoughts in mind as well then, as you go through this section. All the best with it, and I'll catch you again in another section. Cheers!